Alrighty, I want to talk to you about factoring the difference of two squares. So we're going to look at continuing the discussion we had on factoring perfect square trinomials, except in this case we will have signs that are different, so we will not be able to write them as a term squared. This is a little different than what we were doing, but it is very much connected. Okay, first let's consider this. Let's start off by using the FOIL method to FOIL this out and see what kind of answer we get. So we'll take the x in the first term, multiply it by the x in the second term for the f. We'll take the x in the first term, multiply it by the 4 in the second term for the o. We'll take the negative 4 in the first term, multiply it by the x in the first term for the I. And finally, we'll take the negative 4 in the second term and multiply it by the positive 4 in the second term for the L. Let's go through and write out what we've just looked at. So we'll have x times x for the F. We'll have the plus x times the 4 in the second term for the O. For the I, we'll have negative 4 times x. And finally, for the L, we'll have negative 4 times a positive 4. We go through and simplify. We'll have x squared. We'll have plus 4x minus 4x minus the product of negative 4 and 4, which is negative 16. If we simplify this further, we can tell that we're going to have this middle term go to 0. So we're just going to be left with x squared minus 16. And that is actually a binomial because we only have two terms. And if you wanted to factor, you would get what we originally started with, which was these two terms, one being x minus 4 and the other being x plus 4. So we're going to try to go to having two terms and getting a binomial or something similar to that. Let's look at some examples. For example 1, we have x squared minus 49. Okay, first we'll want to open up our sets of parentheses. The coefficient is 1, so just write an x in both sets. Since we have looked at one very similar up here, we can tell our signs. One will be positive, one will be negative. Alrighty, so what happened here, 16 is actually a square, a perfect square of 4 times 4. So that's where we get the 4 and the 4. So now we're looking at a 49. 49 is a perfect square of 7 times 7. So we can write a 7 and 7. And if we were to FOIL this out, we would get it where we started here in the black, because the middle terms of the x times the negative 7, and then we have the middle term adding positive 7x, giving us 0, just leaving us with the x squared minus 49. Okay, if we are to look at number 2, we can see right away that 25 is a perfect square of 5 times 5. So what I would do is open up parentheses, and I would write 5 in both places, and then we can see that m to the 4th is also a perfect square that can be broken into m squared times m squared. So let's write m squared along with the 5 for the first term. Okay, to conclude this part of the problem, look at 1. 1 is actually a perfect square of 1 times 1. And using our rules for these type of problems, we want a plus and a minus. So let's just write a 1 in for each place. And that is how you would factor that. Okay, looking at one like number 3, we see x squared minus 144y squared. Well, if we look, we know that x squared is a perfect square of x times x, and 144y squared is actually a perfect square of 12y times 12y. So we can actually go ahead and open up our parentheses, write the x in for both places, because that multiplying out with FOIL would give us the x squared. Okay, if we use our sign rules of one being a plus and one being a minus, we just discussed that 12 times 12 would yield 144, so let's write a 12 in both places. And finally, to conclude with the y squared, we'll write a y in both sets of parentheses. And that is how you would solve something by factoring for that type of problem. And finally, to conclude with an example like number 4, if you look, there is something that will go into both terms. 5 will go into each term, because 5 will go into 5 and 5 will go into 25, 5 times. And also we will be able to factor out a variable with an exponent because both contain an x, and we can pull out the x squared because it's the least of the two terms. So we can actually pull out a 5, and we can pull out an x squared. And we go through and factor just by saying this first term, 5x to the fourth, divided by the term we're trying to factor out, or 5x to the second, which will be left with x squared. And over on the right side we have a negative 25x squared divided by 5x squared, and we have a negative 5. And with that we can close parentheses. And if you look, 5 can actually not be broken into anything further because it is not a perfect square of anything. 25 is a perfect square, but once we simplified, this trinomial is actually simplified as far as it can go.